Hi, I'm Sebastian Villada, and I'm a master's student at the University of Toronto researching freight transportation. Let me start by asking a short question. What does the future of road transportation look like to you? Everyone's answer will differ, especially for Back to the Future fans who are still patiently waiting for hover cars and Havoline stations. While flying cars may be uncertain, one thing is clear. The future of road transportation won't be dominated by fossil fuels, but instead clean energy vehicles will be driving the world forward. We already see countless EVs from nearly every manufacturer on the roads today. But what about electric trucks? Are they feasible, especially in Canada's frigid winters? This is the very question I will be exploring in my thesis, and one I am very eager to delve into, and one which has significant implications for Canada's climate goals. Electrification is key for Canada's climate target of net zero emissions by 2050. Many clean and existing technologies like our toasters, washing machines, and now our cars are running on electricity. All this requires massive amounts of energy and can seriously hinder the grid without proper planning, as energy supply must always meet energy demand. To ensure a successful energy transition away from fossil fuels, energy providers, grid operators, and energy resource policymakers need to have clear projections of the electricity usage for all these newly electrified sectors. As trucks emit nearly 7% of Canada's emissions, not only are they a key candidate to electrify, but if electrified, will need huge amounts of electricity. So how do we get these projections? Well, this is where my research comes in. The electricity usage from electric trucks comes from their charging profile, which details the time of day and electric power used by electric truck charging. Charging profile assessment is an emerging research topic that usually involves two phases. The first is getting truck travel data, so statistics like distance traveled and rest times, and the second phase is estimating the electric power required to charge and fulfill these truck trips. My research will follow these exact two phases, with the key novelty being the source of my data. While most studies, including those in Canada and Europe, have historically relied on US data, I will be using truck telematics data provided by Transport Canada. Leveraging this high-resolution GPS data will allow me to create detailed truck operation schedules that can identify distance traveled, rest locations and durations, speed, elevation gain, for thousands of trucks operating throughout Canada. The second phase involves applying a charging model I developed to calculate electricity demands. The model uses the truck operation schedules, which are from the GPS data, while incorporating key parameters like existing battery sizes, charging rates, and charging strategy. This model outputs the charging profile, which shows the electric power reported hourly for a fleet of trucks. The two most important aspects of my research, I believe, will be the use of local Canadian trucking data and the application of charging strategies. Charging strategies are applied in the model and influence the behavior of how charging occurs, specifically the duration, the start time, and the power used. A minimum power charging strategy flattens the demand curve, easing strain on the grid, while an immediate or greedy strategy causes the most significant spikes, which in turn causes the most significant strain on the grid. And by using local data, I can better capture the nuances of Canada's unique transportation and climate conditions. With detailed profiles, we can better inform strategy for electrifying freight, ensuring our electricity grid can adapt while meeting the needs of a low-carbon economy. In closing, electrifying freight transportation is a monumental step towards a sustainable future. By leveraging data and innovative modeling, we can make informed decisions that bring Canada closer to its net zero goals. And who knows, while flying cars may still be on the horizon, the roads ahead might soon be filled with electric trucks, driving us towards a cleaner, greener world. Thank you very much.